Alright, so my solvent has traveled to very close to the top of my TLC plate. I've taken off the tin foil. I'm going to pull it out, and I'm going to take and mark a pencil line across the top that shows where the solvent got to across the whole width of the TLC plate. I will then allow this solvent to evaporate, and then I will transfer it, again holding it by the sides, to the development chamber. Alright, so now I've taken my TLC plate and I've put it in the visualization chamber. In the last video I called it the development chamber. The development chamber is the chamber with the solvent in it. So I'm visualizing where my analytes traveled from the origin line, which is down here at the bottom, and you can maybe see my fingers dancing on the bottom, and you can see the line at the top of the TLC plate where the solvent, that's the solvent front. And now what I'm going to do is take a pencil and mark which is a little clumsy. I'm going to mark these spots. Just going to put a circle around them. And once I've done this, once I have marked all the spots and put a circle mark around them, I don't want to carefully trace around the outside. I'm going to pull it out of the TLC chamber, pull it out of the visualization chamber, and then go and calculate my RF values. Alright, now that I've marked my analytes on the TLC plate, I can see that this analyte traveled from the origin point to here, and that the solvent traveled from here to here. And I want to measure those distances in order to calculate my RF. The calculation for RF is explained in your textbook, and you will use these RF values to determine what materials are in your unknowns and identify the unknown analytes by comparing the RF values to the known analytes on this side of the TLC plate. And that's thin layer chromatography.